In this video we're going to do a little more with finding area and review how to use our calculator and kind of extend our work to some word problems. So first of all we're going to find the area from 0 to 3 under the line 4 minus x. So remember, the integral just means finding the area. So what we're looking for here is all of this under the line up to 3. So from 0 to 3. Okay. Now, I think a lot of people would look at this and say, geez, I think the easiest thing to do would be to separate this and make it into a small little rectangle on the bottom and a triangle on the top, and that would certainly work. I'm not going to do that. I'm going to do this as a trapezoid. So first of all, we need to remember the rule for a trapezoid. Remember, it is 1/2 base 1 plus base 2 multiplied by the height. And the bases are the parallel sides. And I say that because that's the sign for parallel. Remember, it's not 11 sides. These are the parallel sides. I say that because a lot of times people are used to seeing a trapezoid that looks like that. But certainly trapezoids don't have to look like that. They can look a lot of different ways. So let's look at this real quick. The parallel sides, you notice, are the vertical sides. So if we can kind of substitute in here, 1/2 base 1 is right here. That's 4 units. Base 2 is over here. It's the other parallel side, so that's 1. And the height is how far apart the bases are. Well, that's just 3. So we've got 5/2 multiplied by 3. We've got 15 halves. Water is draining out of a tank. The rate at which the water is draining can be modeled by that equation. Now, the integral, we've done a lot of work with velocity and saying, if you want to know how far, you find the area or integrate the velocity. But it works for any rate. And here we have a rate at which water is draining out. So the integral or area under this rate equation would tell me how much water is drained out. So it works for any rate equation. It's just a matter of keeping all your functions straight. This first thing says, what is the rate of draining? Well, we have that. We have an equation that tells us the rate. So all we need to do is plug in 5 to the equation. Now, I've got a couple things here. You see this first little picture. I would always recommend putting an equation, especially one that looks a little bit ugly like this. I would always recommend just putting that in my y1, and the reason for that is then you only have to type it in once. You don't run the risk of making a mistake. So I type it in there, and then I say, well, I want to know what it is at 5, so I could either do a table or I could use some function notation. I did that right here. I just plugged 5 in. So, you go to vars and get your y1, and just make sure you put parentheses around it, otherwise it multiplies it by 5. We don't want that. So the rate is 2.943. Remember, we're always using 3 decimals. Okay, I'm kind of toss this one out of the way. Next, set up an integral to find out how much water is drained. Well, the integral, of course, we're going to integrate my equation. We could either write the equation 8e to the negative 0.2t, or we could just say it's the draining equation d of t dt. That looks a little weird, but remember, we just need to put this at the end, dt, because that is telling us what the variable is, and it's time in this case. Our bounds will be from 0 to 5. Well, I'm going to use the next question says solve the integral using technology, so I'm going to I'm going to use FN int on the calculator. If you forgot where that is, remember you go to the math menu, right, math, and it's choice number 9, FN int. Okay, so once we've done that, we've got that out on our blank screen. It looks like this. Remember, we already had that in y1, so we do y1, comma x, because x was our variable. We didn't put t in. X was our variable, lower bound, upper bound. So the answer was 25.285. And remember, we always want to round correctly, and we definitely want to use 3 decimals. So 25.285. And this would, I didn't give you a unit. It would probably be something like gallons or liters or something of water. And the integral, integrating the rate, tells you how much. Okay, so integrating a rate tells you how much. So, if you were doing something like the rate at which snow is falling, you'd integrate it, you'd find out how much snow fell.